Chapter 6 is about solving systems of equations. So far this year we've been solving just one equation at a time. In this chapter we're going to come up with, there's going to be problems where we're given two equations and we want to solve them. So in this first section we learn how to solve systems of equations by graphing. Then there's also substitution, elimination, and there's another method too that we'll get to called solving systems using matrices, unless we don't have time or we get far behind or something, but most likely we'll learn how to do that as well. So the reason that we solve systems of equations is going to become a little bit more evident after we graph this first system right here. So let's graph the first equation, y equals x plus 2. How do I do that? So yeah, start at the y-intercept. So I'm going to use blue for this one. Start at the y-intercept, which is 2, and then what happens? Yeah, the slope is 1 over 1. So up 1, right 1, over and over. Reverse it, down 1, left 1, over and over. Get all those dots on there. Those dots are going to become very handy for us in this section. Then draw in your line as accurately as you possibly can, all the way through the grid that you're given. Just like usual. Now on the same graph, we're going to put that next equation, y equals 3x minus 2, on the same graph. So, I'll use red. How do I graph that one? Negative 2 on the y-axis, that's right. And then what? Up 3, and then right 1. That's a rise of 3 and a run of 1. Our slope's 3. And then I do it again. Up 3, right 1. And notice that I just landed on the dot that I put from my other line. Up 3, right 1. Reverse it, down 3, left 1, and then I'm out of room. Draw on that line, all the way through the grid, as accurately as you possibly can. So what happens here is the whole point of this chapter, basically. We just graphed this line in blue. And the line that we drew, remember when we graph, we're showing all of the ordered pairs that work for this one equation right here. So this line that we drew represents all of the ordered pairs that work for that blue equation. And then on the same graph, we graph this guy in red. The line that we drew represents all of the ordered pairs that make this equation true in red. And these two lines crossed right there. So what is true at that point? That is the one ordered pair right there that works for both equations. So that ordered pair, if I read it off the graph, is 2, 4. That ordered pair works for both equations. That is the only ordered pair that does that. And that is the answer. That's the solution. When I say solve, that's what we're looking for. So at the bottom it says the two equations intersect in a single point, and that single point is the solution of the system of equations. It's the only point that works for both equations. We have an infinite number of points that work for the blue equation. We have an infinite number of points that work for the red equation, but only one ordered pair works for both. And I wanted to show you that that actually is true. We have 2, 4. So if I plug in 2, 4 here, I have 4 equals 2 plus 2. Is that true? Yes. And here I have 4 equals 3 times 2 minus 2. Well, 3 times 2 is 6. So 4 equals 6 minus 2. Is that true? Yes. So that ordered pair, 2, 4, when I plug them in, here and here, works for both equations. And that's what the graph showed me. That's what this section is all about. Graphing two equations on the same grid and figuring out where they cross and writing down that answer as an ordered pair. So therefore this entire chapter is about finding that ordered pair. Where two equations, when they cross, what that ordered pair is. We're going to come up with lots of different ways to solve these systems of equations, but they're all saying exactly the same thing. What ordered pair makes all of the equations true? All right. To solve a system of equations by graphing, here are your steps. First of all, it's going to be easiest most of the time to put both equations in slope-intercept form. You might be given an equation, or you might build an equation from a story problem or something in standard form. And if it's in standard form, a lot of times you can graph using intercepts, and that's perfectly fine. But most of the time, you're going to want to put both equations in slope-intercept form. Then graph both equations carefully as you possibly can. Because if you're sloppy on your graphing, then you won't be able to pick out what that actual intersection point is on your graph. So be careful. Put as many dots as you can, like we've been doing all year long on your graph. Write down the coordinates of the intersection point. It's going to be an ordered pair. Something comma something, x comma y. You have to write that down. If you don't write that down, then you have not given me the answer, which means it's wrong. I have to see that ordered pair. And then finally, check your answer in both equations, just like we did in the last problem where we took the ordered pair and we plugged them into both equations. It's easy to do, and it's good practice, and it helps you make sure that you are right. If you're wrong, then check your equations. You probably graphed something wrong. Usually it's a sign that's wrong. You graphed a positive line when it should have had a negative slope. All right, so here's another example. Y equals 2x plus 4, y equals x plus 2. I'll graph that first equation, y equals 2x plus 4. We have a y-intercept, and I'll graph it in blue. We have a y-intercept of 4 and a slope of 2. So how do I do a slope of 2? Up 2, right 1. I'm out of room, so I'm going to go the other way. I want as many dots as possible, so down 2, left 1, over and over. Carefully drawing that line all the way through the graph. Pay attention to those dots that you put down, because most of the time in this section in Algebra 1, your dots are going to land on each other, and that's your obvious answer. Okay, the second equation, I'll graph in red again. Y equals x plus 2. We have a y-intercept of 2. And what's my slope here? Yeah, up 1, right 1. So up 1, right 1. There we go. Reverse it, go the other way. Down 1, left 1. Down 1, left 1. And notice that I landed right on that same dot, so I already know my answer. But I still have to continue the graph. I still want to carefully draw in that graph. And now what do I need to do? I need to write down that ordered pair where they cross. Where do these two lines cross? -2, 0. I have to put that somewhere on my graph. It doesn't have to be enormous like I just wrote it, but I got to see it. It's got to be an ordered pair. If you don't give me that, then you did not complete the problem and it will be wrong. You got to tell me what the intersection point is. And is that it? We should check it to make sure that you did it right. So I'm going to plug in -2 for x, and I'm going to plug in 0 for y. So if I do that with my blue equation, I have 0 equals 2 times -2 plus 4. So that's 0 equals -4 plus 4. So is that true? Yes. And the other equation, I get 0 equals -2 plus 2. Is that true? Yes. So because we got a true statement in both equations, then this is the correct answer, and we're done. (10 through 18 all), what is that, 9 problems? They're all graphing, just like this. You already know how to graph. Do it carefully. Find the intersection point, write it down, check it to make sure. If you don't write down the checking, you can do it in your head, some of you, and that's fine. Just always check to make sure, especially on those even ones. Now that we know how to graph a system of equations, we need to learn how to handle a story problem, which is going to ask us to do basically the same thing. Well, in story problems, you will need to come up with the equations. You've been doing this all year long. The only difference now is that there's going to be 2 equations to come up with. So you just got to be careful about which information goes with which equation. But after that, you would come up with the two equations and you have exactly the same thing going on. This is the story problem right here. Once upon a time, there were two alligators. One alligator weighed 4 pounds to start and then gained 1.5 pounds per month. The other alligator started out weighing 6 pounds and then gained 1 pound per month. After how many months did the alligators weigh the same amount? So we have two alligators here. Alligator 1 and alligator 2 goes with equation 1 and equation 2. So for alligator 1, it says one alligator weighed 4 pounds to start and gained 1.5 pounds per month. Then it says the other alligator started out weighing 6 pounds and gained 1 pound per month. Those are the two bits of information for our two alligators. My first alligator will be one equation, my second alligator will be the second equation. And all I'd have to do is define variables. X equals, Y equals. What are the things that are changing in this problem? The weight and time. So which one is the independent variable? Which one should be my X? Time. X equals time. Months. So the number of months that have gone by. And so therefore Y must be what? The weight. Okay, and we are looking for when do they weigh the same amount. So what we're going to do is come up with two equations. And where those equations cross, they will weigh the same amount, because at that point, the x's and the y's are both the same for both equations. They weigh the same amount. All right, so for my blue line, one alligator, alligator 1, I need an equation. It's going to be basically the alligator's weight is equal to, the alligator started off at how much? 4 pounds. And then gained 1.5 pounds per month. The pounds per month, remember that word per? I always say kind of gives away the variable. So it's going to be, we're gaining, so plus 1.5 pounds per month. X is my months. So there's your equation. My other equation is going to be what? Y equals, started off at 6 pounds, and we're adding 1 pound per month. 6 plus 1x, or if we were to write that in slope-intercept form, so correctly, we would write what? 1x plus 6, yeah. So even though these terms are in the wrong order, we can still say that this is slope-intercept form kind of, because now we can graph it. So let's graph that blue one first. How do I do that? All right, and now before we graph this, I'm going to point something out to you. Just because I give you a grid that has axes on it doesn't necessarily mean that you have to use the axes the way that they're given to you. You can put the axes anywhere. Is it going to be good to have the origin right here in the center? Why not? Yeah, we don't have any negative numbers. We don't have negative time and we don't have negative weight. Otherwise, these alligators would be floating around and that'd be pretty dangerous. So, can I put my origin in the lower left-hand corner? Yes. And that's exactly what I'm going to do here. What goes on the x-axis? Yeah, time. That's months. Okay, and then on the y-axis is the weight. So the reason that I'm doing that is because I don't have any negative numbers. And remember, if you're dealing with a story problem, there's labels that you have to put on things. So make sure you're doing that. We know how to do that. We've been doing it all year. Now I can go ahead and graph that blue line. Where do I start? 4. So I put my dot there. And then a slope of 1.5. How do I graph that? Okay, you're saying that 1.5 is the same as 3/2. That's true. If you can convert from decimal to fraction, as I've been asking you to do all year, then you can turn that into up 3, right 2. If not, then just put that 1.5 over 1 and go up 1.5, right 1. Up 1.5, right 1. Up 1.5, right 1. Up 1.5, right 1. Or use the 3/2. Up 1, 2, 3, right 2. Up 1, 2, 3, right 2. Up 1, 2, 3, right 2. Now I have as many dots as I can get on there, so I'm going to draw on that line. So there's my line for that one. I noticed that I did not draw it continuing in this direction because I know that I can't have a negative time, and I know that I can't have a negative weight. So I started it here, and then I just drew it up this way. This alligator, according to this, could continue to grow for forever and eventually become like 1,000 pounds. The red line we can graph as well. How do I graph that one? Start at 6, which is here. And then slope is 1, so up 1, right 1, over and over. And notice that we're going to land on that dot right there, just like on the other line. So I continue to draw this. I'm still going to have to draw in my line to complete the problem, but I already know what my answer is. Where did those two lines meet? Remember, our origin is here, so 4 comma, it's not 3. Our origin is all the way down here. So that's actually 7, 8, 9, 10. 4 comma 10. Be careful with that one. When you move the origin, remember that you moved it. So 4 comma 10 is the ordered pair where these two lines cross. But this is a story problem, so I need to put that number into some sort of thing that makes sense for me. What does the 4 mean? 4 months. Did they ask me when? Yeah, they said after how many months? Well, now I know. 4 months down the road, they will be the same weight. Did they ask me how much they weigh? No, but we know how much they weigh, actually. How much would they weigh at that time? 10 pounds. Pretty small for an alligator. One more story problem. It's very similar, actually, to the last one. So let's see if we can talk our way through this. We have one satellite radio service, XM, charges $10 per month plus an activation fee of $20. A second service, so what would that one be if we used XM already? Is there another one? Sirius? Is Sirius still around? Yeah. Oh, that's the same thing? See, that shows you how much I know. We'll say there's somebody else's, Bob's satellite music service. Yeah, for sure. Okay, so Bob's service is $11 per month, and he only charges $15 for that activation fee. Which one sounds like the better deal? Bob's or Sirius? Bob's? Well, we'll see. And in the beginning, who's better right off the bat? Like just to get set up and have your first month. You got $30 here, right? And then you got $15 and $11 here, so $26. So just to get started, Bob's is the better deal. But who charges more per month? We have $10 per month here, $11 per month here. So Bob charges more. So eventually, Sirius is going to be the better deal than Bob, right? Eventually. And we're trying to figure out when that happens. It says in what month was the cost of the service the same? After that, who's going to be the better deal? Sirius will be the better deal. But before that, if you're only going to keep this service for this many months, then Bob's the better deal. All right? Okay. So let's see if we can come up with equations. Where do we start? Before I can even graph it, we got to make our equations. How do I make my equations? starts with a D. What?
Donuts? Donut?
Define your variables. Donut sounds delicious, though. So we need to pick a couple letters. We need to decide what's changing here. What's changing? So we're talking about time, which is in what units are time? Months. So number of months. And what's the other thing that's changing? Not monthly bill. That would be the total amount spent. So amount spent. Your monthly bill is $11 per month or $10 per month. But the total amount that you've spent is what we're caring about here. Okay, so there's our variables. We just need to pick a couple letters. X and Y is perfectly fine. Which one's X? The time is usually going to be X. Yeah, the number of months. So we'll call that one X, and then the amount spent is Y. Okay, that's the hard part. The rest of it comes straight out of the problem. So I'll underline for serious, I'll call this one my blue one. That's this guy right here. We need an equation for that. Yeah, Y equals the total amount of money that I've spent equals $10 per month plus the $20 that they hit you with just to sign up and have the privilege of using them as your service. There's your equation. And in red, we'll do Bob's satellite radio service. $11 per month this time, plus that $15 activation fee. Okay, there's our two equations. Now we just graph them. What are we going to do? Bottom left corner is a good idea because we don't have any negative time, and we're not going to be getting money back from either of these services, so that's no negative money either. All right. Anything else we need to worry about? Axis labels. What goes on this axis? Yep. So months and amount spent. Okay, scale. Do we have to worry about a scale this time? Yeah, why? Yeah, we only have 14 lines here, and we have y-intercepts that are even beyond that. So we need to come up with a good scale here. Not to mention the slope here is pretty crazy, 10 and 11. So 2s. That would get me all the way to 28. So I'd be able to put my y-intercept on there, but as soon as I tried to do rise over run one time, I wouldn't even be on my graph anymore. 10? By 10s is going to get it done. We'll see where these two lines cross if we go by 10s. That's going to be tricky to graph, so we'll have to think about how to graph this one with that slope of 11. But this one's going to be nice with that slope of 10. That's going to be easy. All right, so let's draw the blue one on there. Where do I start? Yep, right here. We're going by 10, so 20 is that guy right there. And then I have a slope of 10, so how much do I have to go up on my graph? Just one square over 1 to the right, because my slope is 10, but my scale on the y-axis is by 10s. So I'm going to put as many dots in here as I can. And then we'll draw on that line. Very carefully. Okay, let's see what we can do about this red line now. Where do we start? 15. With our scale of by 10s, that's going to be tricky. Directly in between the 10, which is here, and the 20, which is here. So I got to very accurately try to put down that 15. Now the scale is 11. Or sorry, the scale's by tens, and we have a slope of 11. 11 over 1. It's going to be tough to draw with this scale. So what I'm going to say that you do is you start applying the slope until you get to one that you actually land on nicely. What I mean by that is this. Instead of trying to mark up 11 over 1, I'm going to think to myself, from 15, if I go up 11, where will I be? From 15, if I go up 11, I'll be at 26 over 1. So now I'm like here. If I go up 11 from 26, where will I be? 37 over 1. So now I'm here. If I go up 11 from 37, where am I? 48 over 1. So now I'm right here. 59 over 1. So now I'm close, but I'm not quite there yet. 70 over 1. And is that 70 right there for my other line? Yeah, so I can put that dot right there. I have 2 dots, which is enough. All right, so apply the slope. Instead of trying to put a dot every time, apply the slope until you land on what you want to land on. And now we can draw our line in there, and we have our intersection point. Very difficult to see that, but that is the intersection right there. So the ordered pair is what? Remember that we changed our origin to down at the bottom. 1, 2, 3, 4, 5 months. And what is this price up here? $70. So 5 comma 70 is the ordered pair. But in terms of the story problem, we have to say 5 months and $70. In what month was the cost of the service the same? That was the 5th month that you had spent the same amount of money. So there's your answer right there, and it was $70. So who's the better deal to begin with? Bob's is. Who's the better deal after 5 months? Sirius is. And in 5 months, they will have spent the same amount of money. So companies will do that sort of thing to you. They'll give you a discount. It seems like this is the better deal here with that cheaper initial fee. But over time, when you sign that 2-year contract or whatever, they know that you're going to wind up spending more money. Because they're banking on the fact that you were sitting in Algebra 1 class not paying attention.